that video, but really it's about drawing a picture, and then we're still using our SOHCAHTOA to solve for a missing piece. So angle of elevation and depression goes from like your horizontal line of sight. So if it's an angle of elevation, looking up from a horizontal line of sight. If it's an angle of depression, I'm looking down from a horizontal. So on 2, we have an angle of depression because we have this airplane. So you always want to draw a picture with these. So here's my airplane. Here's my airplane. Here's the wing. Is a height of 2 miles above the ground. So I have an airplane, it's 2 miles above the ground. Here's my ground. The angle of depression from the plane to the foot of a tree. So here's a tree. There's my lovely tree. So the airplane. You always have to think about this horizontal line of sight. Angle of depression from the plane to the foot of the tree. From this horizontal line to the foot of the tree is 15 degrees. Obviously, I drew a little bit more than 15 degrees. That's okay. It's just a picture. So let's reread. An airplane, height of 2 miles above the ground, has an angle of depression to the tree of 15 degrees. And the trick with the depression ones is that we have alternate interior angles here. So if this is 15, this angle is also 15. So you can always find an angle within the triangle that should come out of your image. So here's the triangle I'm going to look at. Okay, you can always find an angle within that triangle. But if it's depression, it's not in the triangle initially, and it's alternate interior angles that we use from parallel lines. So then it says, what's the distance the plane must fly to be directly above the tree? Well, that would be this distance from here to here for the plane to be at the tree. What must that horizontal distance be? So if we look at just the triangle, and you may even want to redraw the triangle as just a plain trig problem. I have 2 miles here, and I have some unknown length here, and I have 15 degrees. And we can use trig to find this distance, or SOHCAHTOA. And what 2 sides do I have? So given that this is the 15-degree angle, here's my right angle. 2 miles would be the what side? Opposite. So here's my opposite side, and x would be the adjacent side. So if I have opposite and adjacent, which trig function do I want to use? Tangent, yeah. Opposite, adjacent, I want to use tangent. So I'd say, well, the tangent of 15 would be 2 over x. Opposite over adjacent. And then I'd put this over 1, cross multiply, and I get x times the tangent of 15 equals 2, and divide by the tangent of 15, and then I need my calculator. So 2 divided by the tangent of 15 tells me that it'd be about 7.5 rounding, so it's like 7.46, and my units is miles. Okay, so the distance from where the plane is now to get the plane over the tree would be 7.5 miles away. Yeah.
I have a question. So is this going to be on the test?
These will be on the test. Remember, you can use your notes. So ideally you have the elevation and depression notes, which will have lots of pictures. And you'll have this warm up, and you'll have the review that we'll go over today. So I'm going to let you try to draw the pictures and get your setup for 1 and 3 for a minute, and then we'll go over these. We'll go over the review. Yeah, go ahead.
We have to not so like we would do 7.
I'd take 7.46 if you wrote that instead of 7.5. That's fine. You should on the word problems try to include whatever units it is, like if it's miles, feet, whatever, meters. The first few on this homework 40 is it's Pythagorean theorem, but they happen to be triples. You don't have to use the like 3, 4, 5 or 5, 12, 13 if you didn't see it. If you did the Pythagorean theorem, you should have gotten a perfect square, which would give you these numbers anyway. So I just kind of filled those in. A squared plus b squared equals c squared. Making sure that c is our hypotenuse. So check those first. Make sure you read directions, like, is it asking for the Pythagorean theorem? Is it asking for trig? What do I need to do? I also have, oh, wait a minute, make sure that I wanted to. I have 6 filled in as well. 6 is not a triple. Making sure 11 is our hypotenuse, so 11 had to be C. It, with just straight Pythagorean theorem, you get the square root of 40. And just a reminder that you should simplify any rad. So 40 is 4 times 10. That's how I get the 2 rad 10 at the end. I left 5, 7, and 8 because I wanted to refresh our memory when we have these radicals for one of our values. So Pythagorean theorem, a squared plus b squared equals c squared, if you want that in your notes. Make sure this is our hypotenuse and these are our legs. So on 5, I'm given the hypotenuse and one of my legs. So I have x squared plus the square root of 65 squared equals 10 squared. And what happens when I square a square root? This will be x squared plus 65. These are just inverses, so it just is going to get rid of the square root and leave the number itself. I don't then square that number. It's just x squared plus 65 equals 100, which is 10 squared. And now I subtract. So x squared equals 35. And we can't leave x squared, so we take the square root of both sides. And x equals, is there a perfect square number that goes into the square root of 35? So it would have to be less than 35, right? So it'd either have to be 4 goes into it, which it doesn't, 9, which it doesn't, 16, which it doesn't, 25, which it doesn't. So I'm just going to leave the square root of 35 as is. Okay. If nothing goes into it, I wouldn't do the decimal version. Was that what you were going to say?
Well,
It wouldn't help you, right? Yeah, because neither of them can simplify. So I just leave it as 35. 7 is similar where I have the hypotenuse and then my side is a radical. So I have x squared plus the square root of 37 squared equals 7 squared, and this is just going to cancel out. So I have x squared plus 37 equals 49. Subtracting 37, x squared equals 12. Now this I can simplify. What's the square, what perfect square number goes into the square root of 12? 4. So this is 4 times 3, or I could break it into rad 4 times rad 3, which means it simplifies to 2 rad 3. Okay, so we want to be looking for opportunities to simplify rads. 8, we're given both the legs and not the hypotenuse, so I'll have the square root of 6 squared plus 3 squared equals x squared. So where x ends up in this Pythagorean theorem just depends on which piece is missing. These are inverses, so it's just 6 plus 9, which is 15. X equals the square root of 15 can't be simplified. 15 is 5 times 3. Neither of those are perfect squares, so just leave it as the square root of 15. Okay, so that's our Pythagorean theorem. From there, we moved into special right triangles. So I did scan these into Classroom and they're on there. You may want to rewrite them on your own paper somewhere. But we have these 2 special rights. We have our 45, 45, 90 and our 30, 60, 90. So when I get to special rights on the test, what I would do is anytime I get to a special right, I write in the pattern around it. So this is a 30, 60, 90. Across from 30 is x. Hypotenuse is 2x. And then I have x rad 3 on the side across from 60. That's my pattern. And for any of them, I need to know what x is so that I can plug it into the other sides in my pattern. I'm kind of ignoring these. I mean, like they're here and I see them, but I'm really thinking about this x. And this one's an easy one because it's giving me the side that's x. So x is 3. If x is 3, now I just plug that in. So my hypotenuse is 2 times x, which would mean the hypotenuse here would be 2 times 3 is 6. My hypotenuse would be 6. X is 3, so plugging that in here would give me 3 rad 3, and I'm done. Okay, for that first one, I just need to plug in x to the other two sides using my special rates pattern. And knowing that it's a 30, 60, 90. When I get to 10, it's no longer a 30, 60, 90, it's a 45, 45, 90. And my legs are x, and my hypotenuse is x rad 2 on my 45, 45, 90. This one's trickier because it's giving me the x rad 2 side. If x rad 2 equals 4 rad 10, to find what x is, I need to divide by rad 2, which I actually don't need to rationalize the denominator here. If you did, you'll end up with the same answer anyway. But because these can be reduced and they're both radicals, 10 over 2 is just 5. I can just divide like I would if they were two outer numbers. So anything that's inside a rad can be reduced with other numbers that are inside rads, and same outer numbers with outer numbers. If you had rationalized the denominator, which we've done a few times, if you multiplied by rad 2 over rad 2, you still would have gotten there. So that would have given me 4 rad 20 over 2. And then 4 over 2 would simplify to 2 rad 20. And then you'd simplify rad 20 to 2 rad 5. Like you'd still get there, but it takes a lot more time. So if you can reduce rads, you absolutely, that's a legal move. If I had a 2 out here, it'd become 2 rad 5. But I can only reduce this 2 with the 10. So I mean, oh, because this isn't in a rad, it's just regular 4 outside. It's this 4 right here. It's not inside a rad, so it wouldn't become 2. Is that what you meant? So now that I know what x is, I'm just going to plug it in. And so this was tricky, but now the plugging in is easy because each side is just x. This is 4 rad 5, and this is 4 rad 5. On 11, 30, 60, 90, the side I'm given is the side across from 60, which is my x rad 3 side. This one's a little easier to solve than on the last one. If 2 rad 3 equals x rad 3, what does x equal? 2. Yeah, I can just cross off those rad 3s. X equals 2. So if x equals 2, now I can plug that in. This side is x. So this side is 2. This side is 2x, which means my hypotenuse is 4. Good. 30, 60, 90. Side across from 30 is x. Hypotenuse is 2x. X rad 3. I'm given the x side. So if x is 2, my hypotenuse is 2 times 2 or 4. This side, if I plug in 2, gives me 2 rad 3. Done. Next one's tricky. This is a 30, 60, 90. So across from 30x, hypotenuse 2x. The side I'm given is x rad 3, and it's a little bit of a mess. So x rad 3 equals 15 halves. I need to divide by rad 3, which means over here it's going to add, when I divide a fraction, that's going to move to the denominator of that fraction. Really what's happening there is like if I have a fraction, let's just pretend we have 5/3, and then I divide that by 2, that's the same thing as saying when I divide by 2, that's the same thing as multiplying by a half, taking half of it, which then that 2 is going to join the denominator. So same idea here. if I'm dividing by rad 3, that really means I'm multiplying by 1 over rad 3, or that's going to just join the denominator there. But that's tricky. I can't leave that, so how do I get rid of the rad 3 that's in the denominator? Rationalize the denominator, multiplying by rad 3 over rad 3. So that's going to give me 15 rad 3 in the numerator. And in the denominator, I'll have 2 times rad 3 times rad 3 is regular 3. The 2 doesn't get affected. It's not a radical. I have 15 rad 3 over 6, which I can reduce. What number goes into both 15 and 6? I can reduce this piece down to, yep, 5 halves. Whew. So that was a tricky one to get x. That's all that I was doing there, is finding what x was. Now that I know what x is, I can plug it in. So 5 rad 3 over 2 here. And for this side, 2 times x, well, that 2 is in the numerator, so it would give me 10 rad 3 over 2. Or I could just cancel that off. I'm going to be multiplying by 2 and then dividing by 2. If I had multiplied, like I said, it would have given me 10 rad 3 over 2, and then that would reduce. So this side is just going to be 5 rad 3. That was probably one of the most challenging ones on here. To solve for x and then plug it in correctly. Then I have a 45, 45, 90. At least I'm given a side that's x. So I know x is rad 10 over 5. So this is rad 10 over 5. And the hypotenuse is x rad 2. So I'm going to do that. X rad 2, x is rad 10 over 5 times rad 2, which would be rad 2 over 1, which gives me the square root of 20 over 5. Can I simplify the square root of 20? The perfect square number that goes into 20. 4. So this is going to become rad 4, rad 5 over 5, or 2 rad 5 over 5. This side, 2 rad 5 over 5. And that's just determining if this is x, then what's x rad 2? So I have to do some work to get that x rad 2 side. 15 and 16 should have been a little bit easier ones. So 15, side across from 30 is x, 2x, x rad 3. I'm given the side that's 2x. So if 2x equals 18, what does x equal? 9. So now I just plug that in. 9 here, 9 rad 3 here. Okay. Chance, can you put that away, please? Same thing on 16. It's a really easy plug-in. X, 2x, x rad 3. I'm given my x side. X is 5, which means my hypotenuse would be 10, 2 times 5, and this would be 5 rad 3. Just plugging it in. And 17 is a little bit trickier. Not too bad though. X rad 2. I'm given my x side, so this is also 7 rad 2 over 2. This is 7 rad 2 over 2 times rad 2. What happens when I take rad 2 times rad 2 in this numerator? Rad 2 times rad 2 is rad. It's just going to be 2. Yeah, it's going to be rad 4, regular 2. Rad 2 times rad 2 is regular 2. Over 2 times 1 is 2. These cancel. This side ends up just being 7. 18, another one where it gives me the hypotenuse in a 30, 60, 90, but it's a little bit trickier because the hypotenuse doesn't divide by 2. So it gives me the 2x side. If 2x equals 9, x is 9 halves. So just a little trickier to plug in. So this side is 9 halves. And this side is 9/2 times rad 3, or 9 rad 3 over 2. Still no like solving needing to take place really, but it's just trickier because it's a fraction. So, things on our test that we've talked about so far, Pythagorean theorem, and then special right triangles. Now, special right triangles, I can't use the Pythagorean theorem to solve because I need 2 out of 3 sides to solve. Now, fallback method on your test, like let's say I knew 2 out of 3 of these sides, so I got to here, and I got stuck on the x rad 3 side. If I end up using my special rights to find one other side, I could technically then switch to Pythagorean theorem. Like if I had gotten this one here, and I knew that that was 2 and that was 4, I could say 2 squared plus x squared equals 4 squared and find this last side. If you really get stuck on one of the sides for the special right. Once you have 2 sides, I could flip over to there, but ideally we just use special rights on those triangles. Yeah. Yes, I'll scan this in after class. Like the key to it, you mean? Yeah. Then from there, so we went, okay, we can solve right triangles using Pythagorean theorem. We can solve them using special rights if they happen to be a special right. And then we went to trig. Now, what this section is not solving. This is just literally writing the ratio. And then if it can reduce, we'll reduce it. So where we're just kind of changing perspectives on how we look at the triangle. So first it asks for the sine of A. So sine being so, or opposite over hypotenuse. What side is, we're gonna have an issue here, right? What side is opposite A? What side is opposite angle A? Well, 9. Do I have my hypotenuse? No, so we have an issue here. If I have 2 sides, how can I find my third? I have 2 sides, how do I find my third? I can use the what? Pythagorean theorem. So first thing, before we even get started here, we have to find this missing side. And we're missing our hypotenuse. This is going to be 1600, right? This is actually a triple. So I get 1681 equals x squared. That could have been an intimidating number, but the square root of 1681 is 41. That was a triple from our notes. 940, 41. So first I had to find that side. Now that I have that side, what is the sine of A? What over what? We said the opposite is 9. Now we know the hypotenuse is 41. We can solve for it. Can I reduce 9 over 41? No. Okay, so there's my sine of A. Then what happens is it asks you to change how you look at it. So now it's saying, well, what about from C? So what's going to change? The hypotenuse will always be the hypotenuse, but what's opposite and adjacent will change depending on which angle I'm looking at. So tangent, which is opposite over adjacent, what is opposite angle C? Which side? 40. And adjacent would be 9. So tangent of C would be 49. Can I reduce 49 at all? 40 is not going to be divisible by 3 or 9, so no. And then same idea here, I'm still going from C, so cosine, which is adjacent over hypotenuse, would be what over what? For C, angle C. Yep. Okay, so this is literally just writing the ratio. We're not solving for the angle or anything. We're just writing what is the value of the ratio. We're going to run into the same issue here where we have to find our missing side. So we have 24 squared plus x squared equals 40 squared. We have to find our missing side first. 40 squared minus 24 squared gives us 1024. which gives us another, oh, it was a 3, 4, 5, right? 3 times 8, 5 times 8, 4 times 8. Okay, so now we're good to go. It asks us to start with angle C. So from C, cosine of C, so adjacent over hypotenuse from the perspective of angle C would be what over what? 24 over 40. Now on these ratios, we can reduce. What goes into both 24 and 40? 8 reduces down to 3/5. Then it asks for the sine of C, which would be 32 over 40. And again, I would reduce down to 4/5. Notice there's my 3, 4, 5 showing up. But for the last one, make sure we switch perspectives. It switches to A. So tangent of A, well, opposite A would be 24, adjacent 32, giving me 3/4. Okay, so you just have to be careful that you're looking from the right angle as we're doing this. Okay, so 19 and 20, we found the missing side. In order to write the ratio, we needed that missing side using the Pythagorean theorem. For 21 and 22, we still need to find the missing sides before starting, but I no longer would use the Pythagorean theorem. I have to use special rights. X, x rad 3. So I would say, well, 2x is 3. So x is 3/2. This one's going to be tricky. So I have 3 here, 3/2, and this would be 3 rad 3 over 2. I don't even think that, well, let's see, sine of m. It's going to be messy. Tan of m. I'm not even going to worry about, I'll fill these in for you, but I wouldn't give you something that's quite this involved. Sine of n, if I do opposite over hypotenuse, would look like this, which is really 3/2 times 1/3. Don't worry about actually finding the trig ratios with these values for our sides. So, and the tangent of m, so opposite over adjacent, that would be this times the reciprocal of this. It gets very tricky there. And then these cancel out, and it just leaves me with rad 3. If you wanted the answers, but again, I don't worry about those two in terms of something that hard on your test. This one is fair though. So here, finding my missing sides, again, it's a special right, x rad 2. I have 7, 7, and this side would be 7 rad 2. Tangent of x, so from side, that's x. Opposite over adjacent would be what over what? Angle x. Opposite over adjacent. Yep. And adjacent would be. So it just becomes 1. In fact, the tangent of y would also be 1. That's always true with our 45-degree angles. It's going to be the same value, so it'll be the number over itself. Sine of y, so now I'm looking from this angle, opposite 7, hypotenuse 7 rad 2. So what I do need to deal with on this one is rationalizing that denominator. And these can cancel actually, so it gives me rad 2 over 2. Or it would have given me 7 rad 2 over 14, which reduces to 1/2. So those were just finding the basic ratios. Then, and I think it's set up the same on our test. I can double check as well. It gives us a section. I'm going to skip this top part and go down to the bottom. And on this section, it says find the missing value using trig, which means we're missing a side, or using inverse trig, which would mean we're missing an angle. So that's how you determine which one you are using. If the x is a side, you're using regular trig. If x, or it never says x, I think it's just like a question mark. If it's the angle you're trying to find, then you're using inverse trig. But for either of them to decide which function you're using, you're using the SOHCAHTOA idea to decide, am I using sine, cosine, or tangent? But then kind of knowing the difference of when I use one or the other helps us with the setup. So on 27, would I use trig or inverse trig? Regular trig or inverse trig on 27? What am I missing? X is a missing side. So I'm missing a side. I should be using regular trig. Okay. So regular trig, here's my angle. X is my what side in relationship to this angle? Adjacent, and this is my hypotenuse. So which trig function should I use? That's your first question here. If I have adjacent and hypotenuse, I should use cosine. And the cosine of 61 equals x over 11. Put that trig function over 1 and cross multiply. X equals 11 times the cosine of 61. Which gives me rounding 5.3. On 28, I again note that's what's missing is a side, and I have in my notes that a missing side is just regular trig. So from this angle, what is the side that's x from in relationship to the 66 degrees? Opposite, and 15 is. And if I have opposite and adjacent, I should use which one of these? Tangent. So I say the tangent of 66 equals opposite over adjacent, cross multiply. And I get x equals 15 times the tan of 66. Which gives me 33.7 rounding for that missing side. 29, still missing side, so I'm still doing regular trig. I from 52 have opposite in the hypotenuse, so you should have used sine here. Cross multiply, x equals 10 times the sine of 52. X equals 7.9 rounding, it's 88. And if you put 7.88, I'd take it. I'm not going to be like super strict about that. I want to make sure you know how to solve it correctly. From 31, same idea, still regular trig. We're missing a side. This is opposite and hypotenuse again. So sine of 21 equals x over 18. Cross multiply. X equals 18 times the sine of 21. None of those we had to divide. No, I just want to know, right? All of those I ended up multiplying, but I don't want you to look at this and think I always just multiply those two together, right? So there was one in our warm up. Sometimes when we cross multiply, we then end up having to divide. Okay, so just like I can see that being something somebody thinks. Be careful there. It was just the way those happen to be set up. Rounding, this is 6.5. Then we get to 31. And what's missing on 31 is the angle. If the angle is what's missing, now we are looking at inverse trig. Okay, if it looks like this, that's when I know to switch to inverse trig. Inverse trig is kind of easier as long as you know how to use the calculator for it. There's no cross multiplying solving involved. It's literally figure out what you have, put it into your calculator. It gives you the angle out. So from this angle, I have opposite and hypotenuse, which tells me to use sine. Okay, so I still need to think about which one am I using, sine, cosine, or tangent. But I'll use inverse sine of opposite over hypotenuse. I don't even care about reducing it. Okay, this is all about the calculator when we get to inverse trig. So I'm going to go in my calculator, inverse sine of 15/27. And that gives me 33.7. And so to the nearest degree, I'll call that 34 degrees for that angle. Okay. Are you using your phone one? Are you going to use your phone one tomorrow though? Okay. I just 15 divided by 27. Okay, and same on here. Now, if you're using the Desmos, if you end up not being here, you're using the Desmos calculator. To use inverse trig, right? I'm going to function, find the inverse function I want. Then you have to go back to the main screen to type in 15/27, and it just pops up over to the side.
Actual fraction in that.
Yeah, the same thing. You just hit the division to make it a fraction. Okay, and it'll just show up over here. You don't even have to hit enter. But it is a little tricky that you have to go to function and then back to main to type in the numbers. Okay. Same on 32. I'm missing an angle, so I do inverse trig, and from this angle, what would 55 be? What side? Opposite. And we have our hypotenuse, so I should use inverse sine 55 over 60. And again, it's all calculator work. Inverse sine of 55 over 60 gives me 66.4, or to the nearest degree, 66 degrees. What trig function should I use on 33? Sine, cosine, or tangent? I would say I have opposite and adjacent. Yep. And it would be just inverse tangent instead, 22 over 44. Again, you could reduce it, but you don't have to. Calculator will figure it out. I hit enter, and I get 26.56, so 27 degrees to the nearest degree. And 34 would be which trig function? Which should I use, sine, cosine, or tangent? Tangent. So the inverse tangent, this is opposite, that's adjacent, of 8/14. And so if you use the wrong trig function, you're obviously not going to get the right angle. So make sure you write down what you did so I can see, like, did you have this right? And maybe it was a calculator error. That would be way less points off than like, I used the wrong trig function. Like I was doing things, Evan, you need to put that away. I was doing things wrong. Okay, that's a big difference in terms of points. So make sure you write what your intention was, and then I'll know if you just typed it into the calculator wrong. Okay. Okay. So there's our trig and inverse trig, and it moves right into the problems we looked at this morning. Okay, so these are the same as this morning. It says the wire is attached to the top of a 75-meter tower, meets the ground at a 65-degree angle. How long is the wire? So here's the ground. I have a 75-meter tower, and the wire is connected to the top of that tower, and it's creating a 65-degree angle with the ground. And it wants to know how long is the wire. Notice you need to draw a picture for full credit on these problems. Okay, so there's my picture. And from that, I need to decide which trig function am I using. Am I using sine, cosine, or tangent? These word problems are still trig problems. We just need the picture first. So which would I use there? Sine. Yep, I have opposite and hypotenuse. Say the sine of 65 equals 75 over x. So here's one where I cross multiply and I get x times my sine function. And this is what I mean. Then I need to divide here to actually solve. So I divide by the sine of 65. By the sine of 65 gives me 82. It says round to the nearest tenth. So that's one decimal place. It's 7.5. So I'm going to round up to 8 meters. Okay. Toboggan, a sled, travels from point A to B. What's the difference between a toboggan and a sled? Or is it just a like synonym or whatever it's called? It's just the same word for the same object? Or is a toboggan different? Is toboggan wooden? Come on. Wooden sled? I don't know. I never called it a toboggan in my life. I've always had sleds. Toboggan travels from point A to point B. If the toboggan travels 130 meters from A to B, so it's traveling 130 meters, and the vertical descent, which it even tells you is AC, this here, so the height up is 50 meters. What's the approximate angle of depression? So what that means is there's an angle here that's matched here. It's saying, what's this angle? What that hill is at what degree measurement? So this is a different application problem where we're not missing a side. We want to know what's the angle. So when we want to know what the angle is, we're going to switch to use what? Inverse trig. So it's really the same as 33 and 34 here. We're going to say, okay, well, I have opposite and hypotenuse, but because I want the angle, I'll use inverse sine, and I'll do opposite over hypotenuse. And that will tell me what the angle is. And it gives me 22.6 degrees. It said to round to the nearest tenth, so I'll leave it as 22.6 degrees. Okay. Phew, so much info. We haven't talked about one thing, and that's what's at the top of this page. So let's go all the way back up, and then I'll give you some time to organize yourself. This is Pythagorean. This was actually first or second day. This is the Pythagorean theorem stuff. It's kind of in a weird place in the review. But these are Pythagorean inequalities where we can decide if it's acute, obtuse, or a right triangle. This was on your first quiz, so you may want to look and see how did I do with this the first time around. Where if I look at my values and a and b squared is equal to c squared, then it's a right triangle. If a and b are less than c squared, then it's obtuse. My writing gets so funny at this time of year because I'm also our home elf writer, and like the elf writes different than I write. And I start like having messy handwriting because I'm falling into elf writing right now. The elf, I write my E's like this, but the elf writes their E's like that. And I don't know if you've ever noticed, but all my S's and 5s I write from the bottom, like I always have. So the elf writes the S from the top, which is really hard for me. It makes it a little, but like everything's a wreck at this point in terms of my handwriting. A and B is greater than C, that's acute. Okay, so we're looking at our values here, and we do want to make sure that C is the largest value that I have listed. And just again, refreshing our memory with these radicals, and really I want to make sure we talk about 24, but I'm going to plug in here. Square root of 6 squared plus 1 squared, how does that compare to the square root of 10 squared? And so for these square roots, again, it's just canceling off. So I'm going to have 6, and 1 squared is just 1 compared to 10, which gives me 7, which is less than 10, right? 6 plus 1 is 7. And so if A and B are less than C, then it's an obtuse triangle. So I need to answer that question. This is obtuse. See that S mess? It's messing me up. I'm writing my S's from the top, which I don't like to do. Now in 24, when I plug this in, so first, I'm kind of checking to make sure that that's C. You should as well. Like in my mind, and you could use your calculator also. You could do, since you have calculators on this, you could say 2 times the square root of 10, which is that last value. And as a decimal, it's 6.3. So that tells me that this is definitely the largest side. Okay, so if you need to use a calculator, that's probably the easiest way to look at it tomorrow. So I'm saying 6 squared plus 2 squared, how does that compare to? These are the ones we have to be careful about when we have a coefficient in front of our radical. So 6 squared, 36, 2 squared, 4, how does that compare to when it's a coefficient and a radical? I need to square that number in front. So 2 squared is 4. And then for the radical part, it's just going to cancel off like it did on the other rad. So it becomes 4 times 10. I just need to make sure I also square that number in front. So then I get 40, which is equal to 40, and this is a right triangle. So I'll do the same. Now the last two are easy because they're all radicals. So obviously the largest number inside the rad, this is my C value. Rad 7 squared plus rad 8 squared. How does that compare to rad 10 squared, which is just 7 and 8 compared to 10, because they're all just going to undo each other. Or 15 is greater than 10. So since I have greater than, which type of triangle do I have? A cube. And same here, rad 3 squared plus rad 7 squared compared to rad 10 squared, which is going to give me 10 equal to 10, or this guy should be a right triangle. 3 plus 7, giving me 10 equal to 10. Okay. So that's kind of our last piece. There's lots of pieces on here. There's Pythagorean theorem, the Pythagorean inequalities, special rights, trig functions, inverse trig functions. Okay, lots to kind of have organized and ready. So you have like 15 minutes, a little less than that, 13 minutes. What you should maybe do is get on your, make sure you have all of this. If you want to come grab this, if you need to take pictures of it, I will put it on there. Make sure you have all of your homeworks in classroom before tomorrow. If you're not going to be here, make sure you make a plan to Zoom in to take that test. You do not want to take this test on like January 5th. Like that would not be ideal. That's a horrible plan. Okay, so if you're not going to be here, make every effort to Zoom in and just take it so you're done. If you're going to be here, it's going to happen no matter what. Okay, so take the last little bit of class, make sure you're organized and ready. If you want to make a note sheet, like write down your special rights, write down like that would be a good use of time. Write down your inequalities, write down the Pythagorean theorem, the special rights, SOHCAHTOA. Have that on one piece of paper so you're not flipping through everything every time. I'll write up here what I would include, if it were me, on that piece of paper, but just to kind of like condense the info into one spot. There's blank paper up there if that's what you choose to do with this time. So I would write it's right. Elf rating. Okay, so I'd write that. Uh-oh. Maybe even just this. Yeah, I will. Get out a little more. Those are kind of like the big pieces. At least it condenses it down a little bit. Doesn't mean that that's all there is, but that's the big one. We'll do a warm-up tomorrow, so kind of anticipate that. We'll start with a quick warm-up before we jump right